Talk Show.
Recorded live.
Hello, and welcome to the Virtualization Security Roundtable podcast, episode number 79. I actually looked today, and we've been doing this since the middle of 2009, and it's now 2012, so it's been a lot of fun. Our panelists today are Eben Rodriguez, who works for eBay as a senior system engineer or architect or something of that nature. Eben?
Something the cloud, security, infrastructure, something like that. Yeah.
Something like that. Boris Strongen, is it Strongen?
Yeah, Strongen's fine.
Boris Strongen is the co-founder and currently VP of Advanced Products at HighTrust with 20 years of experience in software development, enterprise systems, and security. And hopefully joining us later will be Michael Berman, who's the CTO of Catbird, the pioneering industry leader in security and compliance with virtual infrastructure. Myself, Edward Haletke, a.k.a. TechSiWell in the VMware Communities Forum and pretty much everywhere else, and author of the book VMware vSphere and Virtual Infrastructure Security, as well as the book VMware ESX and ESXi in the Enterprise Second Edition, both which are available on Amazon. Our special guest panelist is Gavin Hill, who is the Director of Virtualization and Cloud Security at Bitdefender. He has been bringing security solutions to the market for more than 10 years. Now, Gavin, you've been on this podcast before, but I welcome all the panelists. And we have a two-part podcast today. The first one is, let's talk about what happened at RSA conference. I mean, hopefully everybody went. I know I was there. I met a huge number of folks, but I really didn't see anything that was like earth-shattering from the cloud and virtualization worlds.
I definitely agree with that.
I mean, it was all kind of same old, and matter of fact, at the Cloud Security Alliance Summit, it was almost a repeat of what happened 3 years ago. It's like almost no one wanted to talk about it. That was really odd. What's your take?
Let me try. So, I went to both the CSA Summit and RSA. RSA, I didn't have a lot of time to spend, so I just wandered around the hall, the expo hall, and got stuck in the HighTrust booth. The CSA Summit, you're right. I mean, there was no revelations. The biggest takeaway probably came from Mike McConnell, the former director of national intelligence and the National Security Agency, who just confirmed that the cloud is going to happen because the economics is so compelling. That sounds right, but of course it's no revelation for any of us here.
What was really interesting about Mike McConnell's talk was the insistence that regardless of what you do, you will get hacked effectively. I mean, when you look at it all up and you read about everything, you trundle through what he said, it boiled down to it will get hacked.
And coming from the director of an NSA, that's very interesting, right? So basically he's saying that even the NSA cannot protect you, even if they wanted to.
I don't even know if they could protect the NSA.
Was that in relation to cloud or in general?
In general.
I think it was more in general.
Yeah, I think so too.
But we're at the Cloud Security Alliance Summit, so you have to apply that almost to cloud.
Yeah.
At least I would. I mean, his talk was very interesting. The statistics he brought out were really very inspiring to do better.
Yeah. And also what he mentioned is that the government is trying very hard to secure the government. It's not going to do much to secure the private sector.
Yeah, well, specifically, the mandate and the money funds, the budget was approved only for protection of .gov and MIL websites
exactly.
or domains.
Exactly. So basically what he said is you guys are on your own. You have to protect yourself.
Yeah, the government's not going to do it for you.
Well, they did acknowledge that they can leverage the same technology, but we're not sharing the data downward, basically, too much.
Yeah. I would agree with that.
I can mention I'm actually working here at eBay with Lawrence Livermore National Labs, on sharing data, and we're concerned with the what's in the data. But basically, it's threats, where the threats are coming from, like IP address reputation. And they would love to have our data, but they can't give too much to us because they're part of the team that's actually working with the GOV and MIL websites to detect attacks and compromise.
Mm-hmm.
But you think about .gov and .mil are not just a single website. You might as well just picture them as massive clouds.
Well, exactly, and they have sensors, and they collect data all over, of course, the United States. I'm sure maybe elsewhere in the world, wherever we have those points of presence. But they can tell us sort of what they see in general, but not specifically. And so we're looking for a way to share that information. And I think that what I heard Michael Connell say is that that's something that they're trying to figure out how to do that data sharing in a safe way.
Would a reputation system work? I mean, apply it to the cloud in general. Would a reputation system work for a cloud?
You need to know how the attacks are changing in order to protect yourself.
Absolutely. I mean, all attacks that I know have morphed into other attacks.
So they can't tell us what IP address or who's attacking, but they can say, look for these sorts of patterns.
Well, I think this is Gavin, sorry to interrupt there, but I think in a cloud per se, a reputation system probably has a better chance than in a private entity, purely based on volume and the scale of it, because you do have that opportunity to go ahead and make those correlations between the large amounts of volume that you're having to deal with.
So effectively, you're looking at a big data problem to solve a security issue that's been ongoing.
Yes.
And if you don't have the volume of data, there's no way to do it.
Well, that's what we were hoping to gain, exactly. We're hoping to gain through, like a company like eBay has a lot of data, but we don't necessarily know how to interpret it very well. And we're hoping to gain that knowledge of methods to interpret data from, like, government or whoever is able. You need, it's basically a bunch of scientists figuring out how to look at data differently and make decisions.
Yeah, that's the whole big data concern is how do you interpret what, and even once you know how to massage and manage that data, I have to know the right questions to inquire of the data, and we may not be asking the right questions even now. So the other thing that I noticed was his comment that attacks happen at the speed of the network. And he didn't follow it up, but I actually put a tweet out there that said, but defense happens at the speed of legislation. I really think that. I mean, we're talking about, it seems almost every defense I've seen has been checkboxes in some standard instead of some active defense for real security. Everybody says, oh, we go by this standard, we do this, we do that. But do they do more? Is it just a checkbox? Are we in just a checkbox world these days? I'm thinking virtualization and cloud because, quite frankly, virtualization, if I just follow the checkboxes for any, like PCI or VMware's hardening guide, the DISA-STIG, or even CIS Security's hardening guide, I'm leaving myself wide open to a number of brand new style of attacks.
Another frightening aspect of this is that what Mike mentioned is that many advanced nations, if not most of them, have a national policy of economic espionage, which we claim the U.S. doesn't. But still, what we're up against is actually the resources of a nation state, not just some little hacker somewhere. So that just adds another dimension to this whole thing.
True.
Yeah, and it gets very interesting when they say that the best defense is attack, right? Did you guys hear something about that? The cyber defense, he said he was in the room explaining, I think, to the president, right, what it was he was suggesting, and he's like, this isn't a defensive thing we can just turn on or not. In order to truly defend ourselves, we have to actually initiate attacks. Remember? You guys
but it only took about 6 minutes for that decision to be made.
Yeah, right.
But if you think about it, that's what Microsoft is all about, right? right? The company Microsoft, they have their honeypoint wasp, and you stick this little honeypot somewhere in your infrastructure, and no one knows where it is. And once an attacker hits it, they get basically shut down using the same attack that came in. They use it on the same exact port. So it's an act of defense.
That's kind of similar to...
The problem I have with that...
What's Boris first?
Yeah, I was just mentioning that this is kind of similar to the approach what Mykonos takes. Mykonos Software, which just got bought by Juniper, they introduced these little honey traps into the URL strings themselves and then watch for them to mutate. And from that, they deduce that there's an attack in progress, and they can do a bunch of stuff. So this idea of a honeypot, whether it be a VM on the network or just fragments inserted into the URL string, it seems to be gaining traction.
Gavin?
Yeah, I was going to say the problem I have with that is the biggest issue is most of these are coming from organized botnets, and most of those botnets are infected or compromised machines. So at the end of the day, counter-attacking is great, but you've got to try and find the command and control.
Yeah, you got to find the command and control center. But shutting down the botnet from hitting you, that's a good start, right? If it's pervasive enough and you get hit enough, then that's actually a really good thing. But at the same time, finding the command and control nodes is the only thing you really can do.
Yeah.
What if command and control is distributed? It's not a single node. It's it's ever changing.
That's why I said nodes.
Yeah. It may be a whole network of command and control nodes.
So on the show floor, I talked to a number of different people. The company will remain nameless. I actually went up to them, and they were a company that did scanning and identity and stuff like that. And I asked them, well, how can you tell me how the cloud is done? Can you tell me how safe my cloud is? And what they came back with is everybody still uses spreadsheets. We don't have we're not involved in that. I'm going, you do it for a computer, but you can't do it for a virtual environment or a cloud? I was floored by that answer.
Well, look at the CSA audit points. They're pretty much a spreadsheet.
And you're right. If you look at the CSA's cloud, the little CCM they have, the matrix, it points to other standards that you have to look at and follow, like the SP500 from NIST. SP800 from NIST. Is it automatable yet? Not really. But some of it is. I mean, I would say you and I both were on the CIS security for some of the standards for ESX and vSphere. And I would say a good 75% of those were actually, if not 80 or 90%, were actually queryable of the cluster itself. You can't look at it as a single node. You got to look at it as.
So you're saying it's something you could automate or write a script, right?
If you know your environment and know what you're looking for,
and that's the thing is using a commercial product or even open source like Ubuntu or Linux or ESX or Zen is you can define. For this version, here are the things you need to check, and here's a script that will let you do that. And basically, it's files. But in the cloud, it's kind of there's so many different APIs to worry about. No one has taken the time to automate these checks. And a lot of the APIs may not support the checks that we want. So there's still a lot of work to do to get those APIs to be able to be used for security audits.
So, what else did you guys see on the show floor?
Well, let me I just mentioned Mykonos. I had a long talk with them because I just found their approach interesting, if limited. I don't know if you guys are familiar with Mykonos. They protect web apps by inserting dummy URL strings and then watch for them to mutate, presumably by an attacker, and then they slow down the connection. They send a message to the attacker. They the all kinds of things. So interesting approach, although I thought it was kind of limited because it would only protect against a certain, basically a SQL injection type of attack, and only with a less than 100% probability because it relies on the attacker changing the dummy fragments that Mykonos inserts into the string. Did you guys talk? Do you have any opinions on that?
Well, it was compelling enough that Juniper ended up buying them, and I know that they're very proud of that purchase. I can see a lot of dealing with customers that do web traffic. I can see a lot of uses for that. When you get 1 billion queries per day or 3 billion queries per day, and you can't look at them anymore. When you look at the log files, they're just too big to go through and just scan them saying, did I get an attack, did I not, and so forth. So having a tool like that when you're a massively parallel system could be very helpful. Remember, it's a volume issue.
Yeah. Well, obviously,
I could see that.
Yeah. But it's not 100% defense even against SQL injection type of attacks because it relies on the attacker modifying the inserted fragment. It's not the whole, it's not a modification in any place in the URL string. It's in a specific place.
Well, it's in a random place, I thought.
Yes, it is random. So it's, it's probabilistic in that sense.
Well, that purchase was actually fairly big news at RSA. Let's think about virtualization and cloud, though. Was there anything really new from the virtualization and cloud vendors? I talked to Juniper with their VGW. It has vastly improved, and they have some newer features. They actually tie into Sophos now. I talked to Kaspersky that now has an endpoint client. Endpoint implementation. I mean, I spent some time with Bitdefender. I spent some time with Viata and SourceFire. But, I mean, there was nothing outstanding.
I would agree. One comment I have is one of the themes at the CSA summit was that for the cloud we need the distributed federated identity and access control management. And then the semantic keynote, Enrique Salem talked about basically the same thing. And then I stopped by the semantic booth, and they said that their O3 product, which is the cloud gateway, is precisely that. It's a cloud gateway for distributed identity management and authorization.
But the Cloud Trust Authority was announced 3 years ago.
Yeah, so I'm not quite sure what's different this time.
And I look at what Intel put up there, and I look at what the Cloud Trust Authority spoke about several RSAs back, and I just don't see a difference. Except for one. I mean, it was really interesting that the only thing I really got out of there was in Intel's, they're using because they're integrating with Salesforce, they're using Salesforce as a credential store, which I find very odd.
Yes, I want...
Yeah. You think that's odd, like using Facebook as a credential store? Is Salesforce not trusted? Is that kind of what we're saying?
No, I'm not saying Salesforce isn't trusted. I'm saying Salesforce isn't big enough for a full-blown cloud. Yeah, for an enterprise, people may or may not use Salesforce.
But I thought Intel just uses it just as an identity provider.
It's an identity provider, so it's a credential store as well as an identity store. Right? If it's an identity provider, how does it prove the identity?
Well, obviously it has to store the credentials as well. Apparently Salesforce is big enough by now, in Intel's view.
I would agree.
Am I on?
Yes, you are, Michael. What do you have? You have comments on that?
I have a comment.
Please share.
Well, I was going to say, certainly it's true that Facebook has a bigger membership than Salesforce, but Salesforce has a pretty decent membership in SMB. And in addition to having a lot of SMB users already, Salesforce does support additional auth, I'll say attributes. They track your IP address. You can register systems, mobile devices, and it picks up if you switch. If you start coming in, if Michael Berman logs in from a new device, Salesforce has additional security capabilities that they add in when that happens. So it's not a bad choice for it may, in fact, I would suspect, because they're not idiots over at Intel, it's probably a really good choice for SMB. And so we have to think about what are they targeting with this offering, and I'll bet you it is the SMB market.
Well, it makes sense if it's the SMB, because I agree with you. A lot of SMBs end up using Salesforce. It's just more convenient. But it's a real product for using Salesforce as the identity store. Cloud Trust Authority, when it came out, was a concept, and now it's actually a product as well. So there's more going on in the identity space. But last year it was all about identity. This year it was not. This year was like a typical mix of security companies and practitioners. What I did find
Go ahead.
Go on.
I thought you were done. Hey, well, I was going to say, the other thing you were talking about as I came on was that it seems like they're sort of announcing a product they've already announced. And that happens either, sometimes that's a product reboot.
True.
I'm saying that, maybe it hasn't had traction and they're not giving up, and they have this new relationship with Salesforce, so they're basically announcing it again, right? Hoping that this time they'll get some traction.
Now, at the CSA Summit, I actually thought, switching slight topic here, and then we'll get into the second half of our show. There was one talk by Chris Kemp of Nebula on OpenStack that I found rather intriguing. What was your guy? Even you were there. I mean, Boris, you were there. What were your thoughts?
Do you even want to go first, or?
Well, I didn't catch the Nebula on OpenStack. I did hear about the OpenStack stuff. I think it's great that the cloud managers are getting such mainstream support, and I think the quick little. I think the guy might have had 15 minutes to talk about OpenStack security, and it was very compelling to me because it screams for a CSI benchmark. Yeah.
Another set of checkboxes. Okay.
A benchmark to just say, hey, this is how you secure OpenStack, and it could be like you said, use the MySQL guide, use this other guide, use these guides, and it's a collection, because that's really what cloud is a collection of various technologies. So
okay.
That's what I saw. I think it called out to a big gap. If we could take that little 15-minute recording that he did on YouTube or something, and that could be like hours or weeks worth of work for a whole team.
Boris, your thoughts?
Yeah, so I did go to his talk, and I heard him many times before at various OpenStack gatherings. So, there's a bunch of interesting points. Basically, he's promoting the idea that OpenStack is, in and of itself, is not a product. It's a collection of tools. And therefore, if you want to have a complete and secure installation, you need to harden all the components yourself, or hire somebody to do it, which, of course, dovetails with what Nebula is doing. It's selling a packaged and hardened distribution of OpenStack, right? So hardening the components by yourself is pretty difficult, time-consuming, because it's a bunch of there's a lot of them. Even though a lot of them are proven and well-known components, but the interactions of them can be quite complex, right? So it does draw attention to the fact that hardening of OpenStack is a real issue. Unless you want to go with a commercial distribution like Nebula or Piston or cloud scaling, you have to do it yourself, and there's not a lot of tools to do it. There's a lot of different point tools for different components of OpenStack, like rsync and MySQL and Django and a bunch of other stuff. But to do it all yourself is a pretty daunting proposition. And he outlined a lot of sort of these little components and things that you have to do to really harden it.
And well, not only that, I mean, he did mention one thing is that, and one thing I got out of it actually was that it's really not about the individual components. I can harden the individual components. Anybody can. You follow the guides, you do it. But it's really about the APIs that are available. Those actually have to be hardened as well. It's all about those little interaction points. Those have to be hardened. And I think you really need to start looking at OpenStack, vCloud, Eucalyptus, and any other tool you want to do for doing cloud as an entity that itself needs to be strengthened and hardened.
I wonder
instead
if
of
that's
just
like
looking at individual components.
A new market, or you can have a secure OpenStack installation from Nebula, or take your chances with something else.
Yeah. Well, that's one of the selling points of Nebula. That's how they presenting it. Another point I wanted to make, and it dovetails with the API question, is that in general in the cloud, it seems to me that APIs are becoming really central. They're the glue that keeps that keeps the cloud together. Various cloud services working together through a bunch of APIs. Multiple clouds, interoperating and so on. So the need to manage and secure APIs in general becomes critical. And there was very little talk about it at either CSA or RSA. I think there's one or two companies that kind of offer tools for API creation and management. And it's not just security, it's also performance management of APIs, right? Say, for example, OpenStack has an API server, but that has to be managed for both performance and security. Number of calls has to be throttled and so on. And, of course, every call has to be authenticated and authorized. Just what's your thoughts on that? Do you think there are some good solutions, or this is not an issue?
Well, no, it's more complicated even than that, as I would say. I mean, speaking as somewhat bitterly as an old security guy, I mean, I am just so tired of people creating more insecure protocols and more insecure APIs. They seem to like to not use, protocols that have already been developed and have already been secured, and so they make a new one.
Hey, Mike, were you at the CSA Summit?
I unfortunately could not attend in person.
So there was a guy that got up on the microphone and said just that. Hey, guys, whose responsibility is it? The security guys to tell us how to secure the APIs, or the guys writing the APIs to make sure they're secure to begin with? And nobody took responsibility.
It's a lot harder.
A lot of finger pointing.
Yeah, but it's very difficult to secure these APIs after they've been written. I mean, as the guy who is in this business, right? Building the tools for securing these platforms, it's just really frustrating when somebody does such a I'm going to be a little colorful here, piss poor job in the first place. It just makes it really hard for me to make it secure. And then when I do that, I run the risk of being a point of failure, right? And the minute I do something to get in the middle and make this, API or this protocol more secure, then the first time somebody has a failure, they blame me, whether it's my fault or not. So it's very, very burdensome. And I was just going to say, I'm still looking at OpenStack as a potential market. Unless we get some big push, is Microsoft going to adopt it? How are we going to have a big enough market for security vendors to get serious about doing something about it? It's going to be something that people like cloud providers. Cloud providers love rolling their own solution, right? They're not even going to go to Nebula. My prediction is they're not going to go to Nebula or Eucalyptus, not the big guys. They always want to just build it themselves because that's the cheapest way to do it. They have an in-house staff, whose business is doing that, and that's what they're going to do. But we're not going to see it in the broader marketplace, so we're not going to see a single secure solution.
Are you talking about?
I think that Rackspace
providers
would argue with you on that.
Yeah, I was going to
they
say,
do
are
have
you talking
secure
about
OpenStack.
Right.
Say, why do you talk?
Okay, is OpenStack an API though?
No, OpenStack is a collection of APIs,
Let me ask you this.
tools,
What
and
I mean,
a way of implementing cloud that's different than vCloud Director.
let me. Okay, I know vCloud Director has their set of APIs, and there's different versions, so they can improve it. Does OpenStack as a unit have its set of APIs that?
It has several APIs. It does have basically every major component. Nova, Swift, Glance.
Right.
They all have their own APIs, and then there's sub APIs for, say, the Keystone, the Authentication Authorization Project.
Right.
There is an API server, inside some of these components.
I'm going to stop you here, Eben, because I'm trying to get OpenStack to be on the podcast. So why don't we save that question for them, because we need to move on to the second half of our show.
All right.
Okay.
The second half is Bitdefender just announced a new security solution for virtualization, as did Kaspersky. But Bitdefender seems to be a little bit further along. Gavin Hill, you're with Bitdefender now. You used to be with another company, which will remain nameless for this particular podcast.
Thanks, Ed.
Tell us what you guys did.
Sure. So we actually released it closer to, I'd say, around about October-ish last year. And what the product is called Security for Virtualized Environments, SVE for short. And what we're doing is we're taking advantage as well of the IPsec API published by VMware. So it integrates directly with the vShield endpoint as well as the vCenter Manager. For like Windows infrastructures, for example, Windows virtual machines, you could call it agentless because we're utilizing the vShield endpoint driver. And for Linux environments, as well as any other hypervisor, for example, Hyper-V, Citrix, Oracle, etc., we have a silent agent that we provide as well for environments like that. That's the 30-second high-level overview of it.
So you actually, out of the box, support all the major hypervisors.
Yes. Yeah.
But when you're not on vSphere, specifically vSphere 5, I would imagine, right?
Yeah. So what we, out of the box...
Well, let me finish my question. So if you're off of vSphere 5, you're not on it, say I'm on Zen or KVM or Hyper-V, you are instead using you have to install the agent inside the VM, or you're using an external agent?
So you would install, what we've done is we've created, it's called a silent agent, and you would install that agent within the virtual machine, but it's not a traditional agent. The big thing that we changed compared to the traditional way of doing things is, as everybody knows on the call, you would normally implement a FAT agent, and that agent would consist of the scan engine and the signature files, and it would perform all of the scanning within that virtual machine, right? So what we did instead is we removed all of those components out of the actual agent, and we created a thin agent. So instead of going ahead and having, as everybody knows, a traditional agent uses 5 to 12 second boot latency, as well as maybe 100 meg disk space and 170 megs of memory. Instead of that approach, with the thin agent, our thin agent's using about 5 megs of memory and about 10 megs of disk space on the actual virtual machine, and it has 0 second boot latency. The way we've done this is we've removed the scan engine and the signature files out of the actual thin agent, and all of that processing is taking place within the virtual appliance. So talking in a normal vSphere environment where we're using the agentless approach, as you'd know, with the agentless approach, we're still performing all of that scanning within the virtual appliance utilizing the vShield endpoint driver. Now, with our thin agent, we've gone along with similar school of thought where we still have our silent agent within that actual virtual machine, each virtual machine, but we've removed the scanning, and the scanning still takes place in the virtual appliance. So that's the big difference.
Now, that's interesting. So you're effectively you created your own EPSec?
Correct, yeah, effectively.
Effectively, you created your own EPSec install image.
Yeah, for Zen, Hyper-V, etc.
So for those who, listening to the call, don't understand how endpoint works, currently there is endpoint talks over a vSCSI filter, but to get to it, you're required to install a new driver called EPSec, which will eventually, hopefully, be bundled with VMware tools, so it just happens automatically. So what you've done, and then that forces the opens and writes to go through the vSCSI filter to talk over a vSwitch to the scan engine and the one that holds all the rules, and then that says yay or nay.
Right.
So what you've done is you've written your own agent that basically passes that data over the network directly to the scan engine that says yay or nay.
Right, yes. Yeah.
Is it only on open and write, or are you doing something on read as well?
We're doing on read, so you're able to scan not only file access, but you're able to scan also process and memory.
Okay. Is that the same you get with endpoint?
Yes.
Okay. That's good. That's an interesting way of doing it, because most other people I've talked to either require you to have their full-blown agent for Linux and everything else, or they require you to have endpoint. And then can you fail between the two? Let's say something goes wrong.
You wouldn't. The only time that you may want to install the thin agent in, say, endpoint would be, so for example, and this is a limitation across the board for all vendors using endpoint, the endpoint driver. The endpoint driver, you're able to perform scanning on file access. The endpoint driver is not necessarily going to be able to scan in memory within the virtual machine and any processes. So in cases like that, when you wanted to also scan that, that's where you would go ahead and implement the silent agent as well as utilizing your endpoint driver. So as far as failing over is concerned, it really depends what exactly you want to do from a security perspective.
The other thing is that with endpoint, you actually must have a VM on that machine, where in the silent agent, it sounds like the scan engine could be anywhere on your network.
So what we've done as well is, like, we've taken that same school of thought. So you have to have the virtual appliance. That's where all the scanning is happening. You have to have that virtual appliance per host. So even when you're deploying with endpoint, you would implement one virtual appliance per host. So in essence, one virtual machine per physical host to scan and protect all of those virtual machines housed within that host.
Have you thought about having a hot standby of that particular scan engine virtual machine, just because, if it dies, you're out to lunch. The virus could get in.
Yeah, we actually have implemented that already. We've got something called a watchdog process, and if something happens to that actual virtual appliance, that virtual machine, it dies or is offline for some reason, another one will be spun up immediately.
Are you using the HA agent that's already available, or did you have your own?
We have our own.
Okay.
Yeah, because what happens is, just to expand a little bit on the architecture, those actual virtual appliances are managed via a security console, so that you have central management across your entire virtual infrastructure, regardless how many hosts you have and how many SVAs, virtual appliances you have. you're managing them all from a central console. And that central console will be remotely checking up on everything.
Okay. So anybody else have questions about antivirus inside of a virtual environment? I think this is an interesting approach. Treating everything the same regardless of operating system and regardless of hypervisor.
Yeah, that in essence is our end goal. What we're trying to do is make sure you have the same behavior regardless of the hypervisor that you're utilizing or platform.
That sounds great.
Is there any additional, I don't know what the right term would be, latency because of the scanning when you're going to the scan engine over the network versus the scan engine on the same VM on the same hypervisor? So can you kind of contrast the performance of a VMware environment versus some other hypervisor?
Or Linux versus Windows on a VMware environment?
Sure. Well, let me answer it this way around. What we've done is, as part of the architecture as well, we've built in some types of caching. So as everybody knows, within a virtualized environment, you have a lot of the same similar file types, etc. And when you're scanning a particular file, that specific file, if it's been scanned already, is cached. So we've actually noticed a drastic improvement, and the more virtual machines you have, obviously the more the actual virtual appliance, the security virtual appliance, is caching from a scanning perspective. So you're able to gain higher performance because you're caching more.
Where is cache located?
So are you computing like a SHA-256 for a file and saying, okay, that's identical to this file I've already scanned, I don't bother scanning it?
Correct, yes. And that cache happens on the actual virtual appliance, because remember, that's where we're doing a lot of the heavy lifting of the scanning. So as far as performance is concerned, it really depends on your environment. If you have a very much mixed environment across Windows, Linux, we're going to be scanning and caching the specific file system files based on whatever operating systems are running and how often they're being accessed.
Yeah, so you're getting a big performance boost because rather than 100 or 1,000 independent scanner brains having to do this with no knowledge of what the other scanners are encountering, right, you are essentially creating a central scan intelligence that optimizes the behavior across the the population of systems you're scanning.
Well,
right. So that begs the question: you're going to do this in the non-virtualized environments too? Of course, right? It's a big improvement.
Yeah. So to give you guys a little bit of an insight, we are working on, or we already have a solution. It's our cloud solution, our cloud-based solution, but that actually today still works with our traditional agents. We are working on providing this type of technology with that, where we will enable the caching mechanism across your organization. So, yes,
so is the cache across the organization or just within the host? Because I'm deploying one scanner per host.
Mm-hmm.
Is the cache a scanner, or is it shared between the scanners?
Yeah, at present the cache is per host because you have one virtual appliance per host, and that cache is within that virtual appliance. But that's something that we're looking at in expanding that out. Because you got to remember, we've looked at it from two different aspects. First aspect was how can we drastically reduce the footprint of the actual agent and the performance of the actual agent from a scanning perspective by removing that scan engine and the signature files to a central location. Actually, three parts. Second was the caching mechanism to drastically improve the overall performance. And the third part was the time to protection in reducing that boot latency for that protection time basically down to zero, because now we don't need to wait for the actual silent agent to load the scan engine and the signature files because they're already automatically loaded in the virtual appliance that's running. So that's the three areas that we really looked at on how can we improve upon the performance and the overall virtual machine density ratio per host.
Now let me ask you an audit question, because one of the things, and this is somewhat from a Cadver perspective, so excuse that, but this would be true of any other sort of configuration audit tool. What mechanism would you recommend I use to validate, right? Say PCI requires that, systems in the card data environment have anti-malware, anti-virus. There's even some specificity about, engine updates and signature file updates. How would I validate that in this? And I love this architecture, so don't get me wrong. I want to know how to validate the architecture, validate that the individual systems are being checked. Would the silent agent respond to my configuration tool like a traditional AV engine would, or is there some new way I need to scan for it and know it's there?
Well, before you answer that one, I'm not even sure the endpoint security module that's inside of each VM actually would respond to such a check either.
Well, I'm not saying it does, but I'm already thinking about that. This is yet another architectural twist on that angle. So I'm just saying in general, this is really clever. Maybe you would say you sort of borrowed a page from the way Google anti-spam works, or some of the smarter anti-spam tools work nowadays. But just the same, I still have the problem of control validation or control assurance. So I do need to know a way to check to make sure this stuff is working.
True.
And so one of the ways to check would be to, run through a test file within the virtual machine. But regardless of that, all of the actual actions, so if within a particular virtual machine, if a piece of malware is detected, all of that is logged to the actual virtual appliance within a central quarantine area, per se, in a VMware infrastructure. In a non-VMware infrastructure where we're utilizing the silent agent, that will all still be logged. Actually, the logging is split across both the virtual appliance as well as the silent agent, and all of that can be queried from our audit logs within the security console. Excuse me.
So you could go to the security console and say, were these machines scanned? When were they scanned? Did they find anything?
Yes. Yeah, we have both an audit log as well as a security log.
And do you have an API for remote access to those logs?
Not at present, no.
Do you send that out via syslog Ceph or syslog at all?
It is available in syslog, yes.
Okay. Well, that would cover it. Okay, great.
So anybody else for this? So I have one question. It's kind of a backhanded one, I guess. It's related but not. I mean, the whole thing about antivirus is to scan a machine for a well-known whatever. Right?
Compare it against the signature.
But it's based on a signature. So when you don't know what it is, or the malware has been hardened against your scanner, because that's what people do, why not impose whitelisting as well?
Funny you should mention that.
I didn't even know. Go on.
No, what Ed is saying is antivirus is completely obsolete. So what are you doing about that?
Exactly.
Yeah.
Exactly. I was trying to be politic.
No, that's fine. Look, everybody in the anti-malware game knows that signatures are old and dead. But suffice to say, that is one of the methods, yes, that everybody in the industry still utilizes. But what we do have is we have other tools in our arsenal. One of those is, first of all, our Behave technology. And our Behave technology, in essence, is heuristics on steroids. But over and above that, then, we have something else called active virus control. And what active virus control does well, first let me expand on what behave does. Behave, as everybody can imagine, goes ahead and it'll just run whatever the file process is within a sandbox and see if it looks and smells like malicious code. If it passes through that and everything's good, we have something else in our arsenal which is called active virus control. And what we do with that is we actually monitor the applications and processes within an environment, and we look at what is that process doing, and we put weights on whatever actions that process is performing. And if that process is trying to do something that we predict is malicious in nature, not based on a single action or a single result, but based on a sum of results, then we will go ahead and we'll stop that process or stop whatever action that specific process is trying to perform. So
if you were rootkitted and you were able to bypass and get to the kernel, there's a good chance that actually would never be found. So my question is, for those viruses that are effectively rootkits that do nasty things that are tied into Windows, for example, there's a good chance they've patched the kernel or whatever they need to do to even prevent being found and process identification and all that stuff. So how are you going to handle that case?
We do have IDS built into the solution as well, but that's not necessarily going to protect you 100% against rootkits. Obviously, we do scan for rootkits as well, and we do protect against rootkits. But yes, it is most certainly a problem. We don't have full-blown whitelisting, but the active virus control is moving in that direction.
Okay. Anybody else?
Just to recap, can you go over the hypervisors that are supported? It's the VMware Citrix Zen server,
Sure.
KVM from Red Hat and Ubuntu also, or no?
Not Ubuntu yet. At the moment, we support KVM, Citrix, Red Hat, Oracle, Hyper-V, and that's it for now.
And what was it about cloud managers? Do you support, do you interact with the cloud managers at all, or you go directly to the hypervisor?
We go, actually, we go directly to the hypervisor. What we're trying to do is remain as hypervisor, try and support as many as possible.
Well, it also begs the question, when you start talking about some of the people, when you do cloud design, and tenants want to know that this is basically a hypervisor, so it's literally below the cloud layer. It's bad. But how are you allowing me as a tenant to see the current state of my machines from an antivirus anti-malware code? Are you allowing a multi-tenant portal for me to use? Are you instead switching that data up to allowing APIs so that I, as the cloud provider, can provide that in my own portal?
Yeah, so that's actually talking about, that's not talking about security for virtual environment. That's talking about our other product, which is cloud security. And that cloud security today utilizes our traditional full agent, and you would have to install that full agent to each virtual machine. What we're looking at doing is expanding upon our SDE architecture, where customers will be able to deploy this virtual appliance. So say, for example, if you're talking to public cloud, one would deploy the virtual appliance within their cloud offering, and where their virtual machines are that they want to protect, and then they would install the SIM agents within those virtual machines, reporting to the actual virtual appliance that they're controlling. That virtual appliance reports back to and controlled by the security console, which manages our virtual appliances you have deployed, be it deployed in a public cloud infrastructure or be it deployed in, say, for example, within your private cloud infrastructure.
So how do you see SCE being deployed in something like Amazon or Rackspace or a Blue Lock or whatever? Take it back.
So if you were deploying within, say, an Amazon environment, what you would do is you deploy your virtual appliance, your security virtual appliance, in, say, one of your availability zones, and then any AMIs that are in that specific availability zone, you would have this exact virtual appliance, or security virtual appliance. And then you would deploy your security console. The security console is another virtual machine, and that virtual machine, that security console, then would manage all of your security virtual appliances, which would be deployed across multiple availability zones. But you would
but that's today using the current cloud full agent thing, right?
That would be if you wanted to deploy security for virtualized environments within an Amazon environment, then you could utilize the SIM agent.
But wouldn't Amazon need to deploy that?
No, they wouldn't. You're still implementing your SIM agent.
Okay, but only in vCloud you have to have the cloud admin deployed. Yes, you would true just an agent regardless of what it is. Correct. So you can do either way. So a tenant could say, oh, I could install it just for myself. Yes, correct. That's very nice. So last thoughts, guys, either about RSA or about what we just talked about with independent SCE? Since you came last tonight, you get to go first.
So yeah, I thought RSA was a good conference. There was more awareness about virtualization security, and I'm very impressed by independent architecture. I think we're onto something pretty cool.
I guess I have to agree with more, anyway, when there are people talk about the new world we're living in. The interesting takeaway is that basically everything can be hacked. Nobody's going to protect you, so it's up to you, and you have to do the best you can. So there's a lot of opportunities in there. And this is something, sounds really cool. And see how it does in the marketplace.
As far as RSA goes, I'm really excited about what the cloud has to offer, and I'm glad to see the interest in hardening cloud. Open Nebula. Yeah. So,
Your last thought.
Well, I'd just like to thank everybody for sharing. If anybody does have any questions, please do feel free to reach out. My email address is ghill@bitdefender.com.
And this is Edward Haledke, and I'd like to thank all my guests for attending. Thank you very much. If you guys could stick around for a little bit after I close this down, that would be great. Thank you, everybody.